There is a very important topics in optimization techniques, that is linear programming problem in graphical method. You are giving a function to maximize this. Max z is equal to 3x1 plus 4x2 objective function. This is called the objective function, and this is called the constraint. The constraints are x1 plus 2x2 less than is equal to 4, 3x1 plus 2x2 less than is equal to 6, and x1 comma x2 greater than 0. First of all, in order to solve this, the step 1 is we have to do a table for x1 and x2, and we have to put 0 0 here at first. When So first of all, we have to do this table, and accordingly we have to put 0 and 0 in these two columns. And when we are putting 0 here, we have to calculate the x1. So in this case, when x2 is 0, so 2 into x2 is 0, so x1 is 4, so here it is 4. And when x1 is 0, x2 is 4 by 2, that is 2. Same in this case, when x1 is 0, when x2 is 0, here x2 is 0, then x1 is 6 by 3, 2. And similarly, when x1 is 0 here, x1 is 0, that means 3 into 0 0, so x2, the value of x2 will be 6 by 2, that is 3. So now, as per these two table, we have to draw the graph. First, we have drawn these x-axis and x1 axis and x2 axis, and here 4 0, we have to see according like this column wise. So 4 0, this is a point for 4 0, 0 2, this is the point for 0 2. So we are joining these 2 points to make a straight line. And here 2 0, this point is 2 0, 0 3, this point is 0 3. We are adding these two straight lines, and ultimately we are getting our feasible region. Here in our given constraint, this is a less than sign. Because of this less than sign, we are doing the arrow inside like this. You can see here like this. If there is a greater than sign, then the arrow will be like this at the outside, not in the inside. So this will be our feasible reason. So we have write down the name. This is O, A, B and C. So at O, this point is 0 comma 0. At A, this point is 2 comma 0. At C, this point is 2 comma 2. And right now we don't know the value of B point. So to calculate the value of B point, we are doing the crossing point of B, that is these two straight line. These straight line we are getting from which constraints, or from which function. These two function we are getting this constant point. So by using these two constraint, we are finding out the value of x1 and x2, and putting the value of x1 and x2 in B point. So the value of B is 1 comma 3 by 2. You can see here. So the objective function, we are putting the values in the objective function. So at z at O point, that means x1 is equal to 0, x2 is equal to 0. We are putting x1 is equal to 0, x2 is equal to 0 in our objective function, that is 3x1 plus 4x2. So we are getting our value 0. Z at A. That means we are putting the value of a 2 comma 0, that is x1 is equal to 2, x2 is equal to 0, and we are getting 6. Likewise, at b 9, at c 8. So zx maximum at b 1 comma 3 by 2, its optimal solution x1 is equal to 1, x2 is equal to 3 by 2, maximum is equal to 9. So we have to find out the maximum. We have to find out the maximum point where this function will be at maximum. So the point is b. At b point we will be getting our optimal solution. Likewise, to calculate the minimum of this objective function, the minimum will be 0. So at z at o point we will be getting our minimum required function. Suppose we have to minimize any objective function. We'll be doing the same here, and when in case of minimize we are getting here, suppose we are getting here a greater than sign, greater than equal to, then the arrow will be at the outside. You can see here the arrow will be at the outside, and like this we are finding out the values for each and every points, and at which point we are getting our minimum number will be our minimum optimal solution. So z is minimum at b 1 comma 3 by 2 at n is equal to 1, and x2 is equal to 3 by 2, and minimum z is equal to 9. Now there are some most important points in this linear programming problem graphical method. And the first one is, like in this case, suppose in this case when there is a greater than equal to, that means the solution will be at the outside. So if you have to find the maximum, so there are lots of point will be maximum, right? So in this case we will not get the unbound, will not get the optimal solution, unique optimal solution. We will get a lots of solution, and these type of solutions are called unbounded solution. Another important topic point is objective function this and constraint this. If this objective function and one of the constraint is same, then in this particular case we will be getting infinite solution of our objective function, and the value will not be a optimal unique solution. Suppose you are giving this question, max z is equal to 6x1 minus 4x2, and these two are the constraints of the function. So we are getting these two tables, x1 and x2, and putting 0 0 here. When x2 is 0, we are getting x1 is 4 by 2, that is 2. When x1 is 0, that means x2 is 1. 4 by 4 is equal to 1. In this case, for this table, when x2 is 0, when x2 is 0, 16 by 4 is equal to 4. When x1 is 0, 16 by 8 is equal to 2. And 1 is less than equal to, 1 is greater than equal to. So for less than equal to, the direction will be inside direction arrow, and for greater than, the direction will be outside direction. So there will be no common feasible reason. So that's why there will be no solution of this objective function. There often also an important question comes, that is like this: there are so many constraints, and one is less than, one is greater than, like this. We have to find out the tables for each and every constraints, and we have to draw this graph. I have already teach you how to draw this graph, and accordingly I have drawn this graph. So in order to find out each and every um, these crossing points, that is A, B, C, D, E, we will be doing the suppose we have to find out this D point. So this is the crossing point. The D is the crossing point of 1. So D is the crossing point. D is the crossing point for 1 and 5. So by solving this 1 equation and 5 equation, by solving this is 1 equation and this is 5 equation, by solving these two equation we will be getting x1 and x2 accordingly, and we will be putting the values like this. So after doing this we are getting this. So our ultimate result is z at a 4, z at b, like this, z at e, and we have to find out the minimum solution. So we will be getting the minimal solution at a point. In the next upcoming video we will be learning about simplex method, that is one of the most important method in linear programming problem in optimization techniques.